Hi, in this video clip what we're going to be talking about is cooling the transformer. And what I mean by that is these transformers get hot or can get warm when you use them depending on the load you put on them and the size of the wire you use. So one of the problems I can see is that a person winds a transformer, maybe not so much in America, but in another country, you wind a transformer and you want to step the voltage up to 460, which puts extra load on the transformer. So then you upgrade your motor, you put a different motor on there and you want to run some more stuff, and your transformer can actually start getting warm on you. So the question comes, is it a better way to cool the transformer or just build another transformer? So the thing I'm showing you today is oil cooling the transformer. And this is not, I'm not recommending everybody do this. I'm just doing this so you can see what happens and you can understand, okay, the philosophy of cooling a transformer. Now in the bucket over here, we have our transformer, okay? It's a homemade transformer and it's sitting there in, we've got a bunch of this automatic transmission fluid in there, okay? So this transformer was wound with 12 gauge, we had two 12 gauge wires on it in parallel. So the wire is not exactly heavy duty. You're talking 12, we had 800 feet of 12 gauge copper wire on here. That's about $100 worth of copper wire, $110, $120 worth of copper wire. So we saved money on the copper wire. Now we got the transmission fluid. I bought new transmission fluid for this. And you know, I think you could probably get away with using used stuff that would save a little money there. But anyway, here's the setup. This transformer produces voltage. It's a step-up transformer, so we could run something at 240 volts, which will run the vacuum cleaner. We can run something at 480 volts. It's a dual transformer. We have the two windings on there. I have over here an amp meter that shows the amps going in. And I also have this temperature gauge meter there. That shows I buried a little thermocouple thingy down in the windings of the coil there so we could see what effect this is having, okay? So I'm going to turn the transformer on and then we'll start up the air compressor. Oh, and then shine the camera over here then, Christopher. Up on this box here thing. So in here, in this box, I mean, I put threw the capacitors in here. We have these two, another two. For run capacitors, they're connected up series parallel. We have the start capacitors, again, series parallel. We have our little start relay there. I used a resistor, a 12,000 ohm resistor in the start relay, just because I was having a little trouble and it was quicker to throw that in there to mess around. So we can start our air compressor up. And Christopher, focus it, see if you can read this meter over here. The one I got in my hand here, Christopher. Can you get that one at all? Basically 480 volts input to the motor. You got it, Christopher? Okay, good. All right, so we're running the air compressor. We're running the air compressor at 480 volts. We're doing it with this transformer that you saw earlier that had the two 12 gauge wires on there. And in all honesty, running this at 480 volts, that transformer would start to get warm with the air compressor, especially when the air compressor was under full load. So right now, you know, it doesn't have enough air in the tank to be a huge load. We're only got 14 amps input. But with the oil bath, the transformer is not going to get hot. You know, you're not going to worry about it getting hot. If you wanted to cool the oil, you could buy a power steering pump and a little automatic transmission cooler and hook up a little motor, and you could actually pump the oil through a cooler. So let's start up the vacuum cleaner now and see what happens when we put the vacuum cleaner on. Focus on the temperature gauge, because that'll jack up that temperature. Okay, now we're running the vacuum cleaner. I got this thing on there. And now we're drawing 47 amps through this thing. The air compressor and the vacuum cleaner. Okay, here we are. We have the air compressor running. It's running at 480 volts with our homemade transformer. This is the temperature gauge of the oil. We started up the vacuum cleaner. As you can see, we're drawing a total of 45 amps from this transformer. We're running the vacuum cleaner at 240. We're running the air compressor at 480. We're cooling it in oil. The oil makes a huge, huge difference. You might as well, you got to analyze it out to decide whether you want to cool it in oil or build a bigger transformer. You can buy special transformer oil. I'm using the automatic transmission fluid. You can buy special transformer oil. You can buy green transformer oil, which is biodegradable. If you spill it on the ground, you can hose it off and wash it into the dirt. 10 horsepower. 10 horsepower vacuum cleaner. Okay, here we are. We're running the air compressor and the vacuum cleaner. We've had it on for maybe 15 minutes now. I could look at the film. The temperature is skyrocketed up to 86 degrees for that oil in there. Obviously, it's going to work. You're cooling the transformer with oil. We're running, right here, we've got this meter on here, reading 49 amps. One of the reasons why that reads actually a little lower is because when we run the vacuum cleaner on 240 volts, some of the energy does not go through the transformer because you're really just generating that one leg with the transformer. With the 480 volt air compressor, all the energy to run that motor is going through the transformer. So here we are, we're up at 87 degrees. It's been 15 minutes. We've got the hose off the vacuum cleaner, trying to max that out. We're running the air compressor at almost 165, 70 pounds here. And we're running away, we're cooling it in oil. Okay, now that I turned everything off, it's a little quieter and maybe you can hear me. But the temperature gauge, we're up to 88 degrees. Now this has got a probe down there inside the transformer coils. We ran the vacuum cleaner for 15, 20 minutes or whatever, 15 minutes maybe. It went from 78 or whatever to 88 degrees on the oil. On the amp gauge here, those of you who follow the videos and stuff, I'm feeding in the 240 volts here. The transformer is generating one of the legs to run the vacuum cleaner, but not all the energy for the vacuum cleaner has to go through the transformer. The wires that come out here to run the air compressor at the 480 volts, all that energy goes through the coils in the transformer, because you're obviously stepping the 240 volts up to 480, and then running the whole thing on the 480. So there we have the setup. And personally, I think that the oil cooling is not for everybody. You've got the pot of oil there; it's smelly. As far as a fire hazard goes, I wouldn't recommend trying this at home unless you're really cautious and careful. And unless I want to stress, you got to know what you're doing to do this. I'm not sure if that oil can catch on fire or not. It's got a very high flash point. This is what they use, but of course, I would not put this in my shop and leave it in an open top container or something like that. I mean, you'd have to build this into some sort of fireproofy area where if it, if something caught on fire, there's a lid on it so it can't burn, it can't get oxygen. You'd have a tight fitting lid and maybe a metal container inside a metal catch basin container thing that could be all shut off. Maybe have a fire extinguisher standing by, near it. But the whole thought here is that we're trying to save money on copper wire. And also, if you build a transformer, and the transformer works and it does everything you need, but then you upgrade to a heavier motor, a bigger motor, you might be able to save yourself some money by simply opting to cool it in oil. Or if you're in a country and it's hard to get supplies and parts, or maybe you can't get some used copper wire, some cheap copper wire that's at a discount, and you want to do it like this, you might want to say, okay, let's prepare for a fire hazard, put it in a container, have it in a fireproof area. It's totally quiet when you do this. Actually, one thing I will point out is the transformer, when in the oil, it's almost dangerous because it makes no hum whatsoever. So you really have to be watchful to see whether it's on or not, because I have found just by working on this little setup here, you kind of forget this thing is totally quiet. You're so used to the transformer making a humming noise that you always know when you go near it, it's humming, you're not going to touch it. Here, you cannot hear any noise whatsoever. Matter of fact, it would probably be good for rotary converter people. They can actually put their rotary in a whole bath of oil and you wouldn't be able to hear the noise anymore, probably, but maybe. But anyway, that's the setup. This is the thing was done. The air compressor 5-horse run at 480 volts. Just like you would do in England or Australia or Ireland or one of these countries. You build your own transformer like we've got, and you can decide when you're building it, do you want to go for the heavier wire? Do you want to wind a bigger thing, 8-gauge wire to run a 5-horse, or do you want to go with this and then try and cool it? I would recommend you build something and run motors first before you get into oil cooling, because once you put it in the oil, it's going to be kind of messy to make any change.